All right, ladies and gentlemen, we are going to be starting Unit 6, which is all on circles. So our first little bit here is going to be some circle properties that we have learned already this year, and then that's going to help us with some chord properties. So let's talk about a radius. We actually have three of them here. We have OB, OA, and OE. Radius starts from the center and goes to the edge of the circle. Then we have chords, which would be DC. Another chord would be AB. A chord is going to have its endpoints on the circle. So our radii would not be chords because the other end is not on the circle. But the diameter is actually the longest chord in our circle. And so that brings us to diameter of AB. So that's the longest chord that goes, and it goes through the center. Our center is O. And then tangent. Tangent is a line that intersects my circle at exactly one point. And here it would be T, but we can't just say T. Our line is going to be T, T, G. All right, a few more things. We have congruent circles. So that's when my radii are the same in my two circles. Then we have concentric circles, which are circles nested within each other. So those would be things like, if we look at wheels, the outside circle and the inside circle, or tree rings are concentric circles. Congruent circles would be like two wheels on a shopping cart. They're going to be the same distance. Okay, then we have three types of arcs. We have a minor arc, so that would be like PR. Remember, arcs are written like that. Or we could say RQ. Those would both be minor arcs. They're arcs that are less than 180 degrees. A major arc is an arc that is greater than 180 degrees. So we could say PQR because I'm going around this direction. Okay, and that would be a major arc because it's greater than 180 degrees. Then a semicircle would be PQ, which PQ is my diameter, but PQ is also my semicircle if I mark it with an arc for denotation. Okay, let's introduce some new topics. Central angle. A central angle has its vertex at the center of the circle. So our center is at my vertex in both of these. The central angle and its arc have the same measure. So for here, my arc is 80 degrees, so that means x is also 80 degrees. My angle and my arc have the same measure. If I said this was 55 degrees, that would make this 55 degrees also. Angles or central angles and arcs always have the same measure. An inscribed angle has its vertex on the side of the circle, and its sides are chords. So the difference between an inscribed angle and a central angle is look where that vertex is. Here it's in the center. It's called a central angle. In an inscribed angle, my vertex is on the circle. Okay, if two chords in a circle or congruent circles are congruent, then their central angles are also congruent. Okay, so here I have two chords. They are marked as congruent. And if I draw my central angle here, okay, so I have an arc that's 70 degrees and it's got a central angle that's also going to be 70 degrees. Both of these chords here are congruent, so that means that x is also going to be 70 degrees. So those arcs are congruent, those angles are congruent, and those chords are all congruent. All right, if two chords in a circle or congruent circles are congruent, then their intercepted arcs are congruent. Okay, an intercepted arc is from the ends of those, the end points of the chord or the angles. So it says circle D and circle C are congruent, and I have chords that are congruent. They're marked congruent here and here. So that means these two are equal. So I can say 5x equals 3x plus 54. I can subtract over my 3x, divide both sides by 2, so x equals 27. Because I know my angles are, my arcs are congruent based on my circles are congruent. All right, if the diameter or the radius of a circle, so something that goes through the center, is perpendicular to the chord, and that's shown here with our little right angle, then it bisects the chord and the arc. Bisects, remember, it cuts it evenly in half. So the chord is congruent to each other because of the diameter being perpendicular, and my arc is bisected. So those two pieces are congruent to each other. So that makes the diameter or the radius a perpendicular bisector. So that's called a perpendicular bisector. It's perpendicular to my chord and it bisects it. All right. Then in a circle or congruent circles, if two chords are congruent in the circle, then they're equidistant from the center. So equidistant means same distance. So if my two chords are congruent, so if this is marked congruent here and here, or if they said FG is congruent to JH, then they're equidistant. So that means that these two pieces are congruent to each other. All right, so that had lots of different definitions, but nothing too difficult. Use those to refer back to when you're doing this assignment. It's pretty short, 1 through 10 and 19 and 22.